This is the last in the series of elimination, solving systems with elimination by arranging. To help you understand what we mean by arranging, we're just going to talk about the commutative property and the addition and subtraction properties of equality, which we call inverse operations. So I have two equations, and they're not in the same position. So the first thing I have here is y, then I have an equal sign. I have 5x, then I have a plus sign, then I have y. So these are not in the same location. So I'm going to change them so they are. And I'm going to do that by putting them both into slope-intercept form because we're very familiar with that. So slope-intercept form. And many of you are already thinking, okay, that's y equals mx plus b. I already have the y equals. I need my mx to be over here and the 4 to be over there. That's called the commutative property. So I'm just going to go ahead and commute these two terms. And I remember that I keep the sign with them. So y equals negative 3x plus 4. Same idea over here in this equation, but now I'll be using equality properties, the addition and subtraction properties of equality. We call that inverse operations. So I want the y equals to be here, which means I want to move the 5x with properties of equality. So I subtract 5x, that's an inverse operation. This becomes 0, which is an identity when you add it. So we end up with y equals 4 minus 3x minus 5x. If I combine those, I get minus 8x, and then I just need to commute again. So I use the commutative property again to get y equals negative 8x plus 4. So now we can write this other equation over here, y equals negative 8x plus 4. The terms are lined up, and we're ready to find a factor to scale by, to multiply by, a scalar, and then we can do our elimination. So let's go on to an example problem now that we understand the commutative property, properties of equality, and how we use them.
Okay, so here we have example number 1, and I know that you're thinking, dang, there's 7 steps, but 3 through 7 are steps that we've already gone over, so they're just review steps. So the first step here, when we see our two equations, we want to use elimination, and the variables are not lined up with their corresponding counterparts. We've got to come up with a plan to arrange our three variables, x, y, and the constant, so that we have our constants lined up, our x's lined up, and our y's lined up. So right now what we have is we've got constant, y term, equaling x term. And then in the second equation, we've got x term, constant term, equaling y term. And what we want is we want our constants on top of each other, the y's on top of each other, and the x's. And we want to do this the easiest way possible. So we look here, and if you look at the constants and their relationship to the equal sign, they're both on the left side. So let's go ahead and leave the constant on the left side. And then if you look at the y and x's on both of them, they're on opposite sides. So let's go ahead and just put our x as the first term on the right side, and then followed by our y term, right? So here we have our first equation, negative 5 plus 4y equals 3x. Constant's okay. We need to eliminate the y term on the left side so we can get it on the right. So we're going to use inverse operations. Minus 4y minus 4y. And our new equation is negative 5. These have been eliminated. 3x minus 4y. Now we've got constant x, y, so we're good here. Now let's make sure we arrange this one correctly. Our constant's okay. We want to eliminate our x term on this side so we can get it on this side. So we're going to minus 6x, inverse operations, minus 6x. Then we have negative 2 equals 2y minus 6x. And we got to commute the x term in front of the y because we want xy. So we're just going to commute it by changing the position. Take the sign, you'll be fine. And now you can see they're ready to be eliminated. So I'm going to go ahead and write it right here.
So what we're looking for now is a term that we can multiply by that will cause either the x or the y to eliminate. So if we look at this top equation, we've got 3x and 4y, and we have 6x and 2y. Well, is 3 a factor of 6? Yes, it is. Is 2 a factor of 4? Yes, it is. So we can choose which ones we want. Do we want the x's or the y's? I'm going to choose x's. If I want to eliminate this, what is the factor of 3 that makes it into 6? 2. So I'm going to go ahead and multiply this entire equation by 2. And because I want to add them, I need to make sure that they are opposites. Well, is a 2 times 3 positive 6x opposite of negative 6x? Yes, positive 6x and negative 6x are opposites. So I'm ready to roll. I'm going to multiply this through and write the new equation below. 2 times negative 5 is negative 10. 2 times 3x is 6x. 2 times negative 4, negative 8y. So this equation has been scaled, it's gone, and I'm using these two equations now. I'm going to go ahead and sum them together. Negative 2 plus negative 10 is negative 12. Negative 6x plus 6x is 0, which will become an identity once we add. Negative 8y plus 2y is negative 6y. So I have negative 12 equals negative 6y, and I can use inverse operations by dividing by negative 6 to get y is equal to negative 12 divided by negative 6, which is positive 2. At this point, I continue following the steps, and I reinsert this into one of the equations. We'll go ahead and insert it to our original equation, and we have negative 5 equals 3x minus 4y, and the y is now 2. We simplify. Negative 5 equals 3x minus 8. I can use inverse operations by adding the 8, and I have 3 equals 3x. I use inverse operations to divide, and I have x is equal to 1. These are great answers. As a coordinate point, they look like this. 1, 2. Remember, x comes before y. Or in other words, you have to walk to the elevator before you can go up or down.
Okay, second example. As we go through these examples, you're not filling in the words, you're just filling in the equations as we go through the steps. So if you look at the two equations, we've got x term equaling y term, and there's no constant term. So when there's no constant term, what is it? 0. So let's go ahead and just put plus 0 in front here when we don't have the constant term. And then in our second equation, we have x constant term y. So what's the easiest way to arrange these? Well, we've got constant term on the left side, x on the left side, and y on the right side. So, in fact, the only thing that we need to do is switch the position of our constant term and our x term so that they're lined up. So let's go ahead and do that right now. We're going to commute the x term and the constant term. And our new equation is negative 10 plus 3x equals 4y. So type in this new equation, and then let's bring down this top equation. So we have 0 plus, not plus, we got 0 minus, we don't want to write double signs, 12x equals 24y. And go ahead and type in this equation. Now we've got to look for factors. So 3 is a factor of 12, and 4 is also a factor of 24, but it's a lot easier to multiply by 4 than it is to multiply by 6. So we're going to multiply this top equation by 4, and 4 times 3 gives us a positive 12. Positive 12 is the opposite of negative 12, so we're good when we scalar multiply this entire thing. And our new equation, which you should type in right here, is going to be 4 times negative 10 is negative 40. 4 times 3 is 12x. 4 times 4y is 16y. Now we've got our opposites, so we can go ahead and add. We're going to add, and add. 0 plus negative 40 is just negative 40. These zero out, so we don't even have to write it. 24 plus 16y is a 40y. So here's our new equation. Now we're going to go ahead and solve for y using inverse operations. Divide by 40 to both sides. And we get negative 1 here equals y equals y. So when I take this number in, I'm plugging it in for y because that's what negative 1's equaling. So let's go ahead and use this original equation right here, since we can choose any one that we want. So we have negative 12x equals 24 times, and now we're putting in negative 1 for y. And we get negative 12x equals negative 24. And now we can go ahead and use inverse operations to solve for x. So we divide both sides by negative 12. Here we have just x. Negative divided by negative is a positive. 24 divided by 12 is 2. So now we have the values for both of the variables. We can go ahead and write our answer as a coordinate point. X always comes first in the alphabet, so we write the number first, and y to follow.
Okay, here's the next one. We're going to go ahead and look at x, y. So we've got y, x, c, x, y, c. We just have to commute the x and the y. So we'll go ahead and just rewrite this bottom one. As we commute these to get the y's and the x's lined up, we got negative 4y minus 4x equals 8. I take my other original equation, which is negative 2y minus 3x equals 6. Look for factors. 2 is a factor of 4. 3 is not a factor of 4. That makes it a little easier. I'm just going to go ahead and multiply this bottom equation by negative 2. Why did I choose negative 2? Because that will give me a positive 4, which is the opposite of the negative 4 in the upper equation. So I go ahead and multiply through, and I end up with positive 4y plus 6x equals negative 12. Then I bring down this other equation, minus 4y minus 4x equals 8. And now I can sum these two equations. And I get 0, which will turn into an identity when we add it, plus 2x equals negative 4. I can divide by 2. I'm ignoring this because it's an identity. And I get x equals negative 2. I can go ahead and plug this back in to my original equation. I like to use the equation that is unchanged, just in case I made an error when I scaled this. And I get, I want to use it here just in case I made an error when I scaled it. And I get negative 2y minus 3 times negative 2 equals 6. And this simplifies to a positive 6. So negative 2y plus 6 equals 6. My inverse operation will cause both 6's to become zeros. So negative 2y plus 0 equals 0. This is gone. Divide by negative 2. And y equals 0. As I write it as a coordinate pair, it is x first, just like in the alphabet, y second, just like in the alphabet. And again, you have to walk, that represents the x-axis, to the elevator before you can go up or down. That's the y-axis. You have to walk to the elevator before you can go up or down in the elevator.